Alright, welcome to today's lesson on the DHCP. By the end of this lesson, you will be able to explain the full meaning of DHCP. What is DHCP? The acronym DHCP stands for what? So, this is Dynamic Host Configuration and then the P is protocol. So, in my previous lesson, I explained to you something about IP address. Let me share this screen for you to remember what we said about IP address. During the lesson, I explained to you that IP address comes in the form of 8 octet. If you remember, I explained to you or I said that every IP address has two parts. So if you have 192.168.172 maybe dot 35, the first 3 octets here stands for the network. And then the last octet, which is here, the 35, is the host on the network. So the first 3 octets of the IP address, this first octet, second octet, and then the third octet. These 3 octets stands for, or they stand in the name of the network in which you are connected to. And then the last octet, which is here, the 35, is your host, which is your device. It can be laptop, it can be iPad, it can be your tablet, it can be any device that you have connected on the network. So if you want to read any IP address, then you should know that the first 3 will determine which network you are using or you are connected to. And then the last number or the digit, which is the host, is the ID or is the particular label that has been given to your device, which you have connected to the network. And who does this work? Who assigns the IP address? We all remember when we went to school. Anytime you are about to write your exams, you should have your index number. And who assigns the index number to you? It is the examination body or the registration exams body who assigns those index numbers to you when you want to take your exams. The same thing applies to DHCP on the network. When you bought your router or your modem, there was a configuration by the DHCP to assign an IP address to the device as soon as you are connected to the router. And then it is the work of the DHCP to look inside the router and look inside the address table and assign a particular IP address to your device as it is being connected to that particular network in which your router is the one which is connected directly to the network with the modem. Nowadays, we have what is called small office, home office routers. This small office, home office routers comes in 2 forms. You get one part to be a modem, and the modem will also come with what is called the router. So it is the work of the DHCP in the router to assign IP address. The router itself, when you ping an IP address, you see what's called default gateway in Windows. Now, the default gateway in Windows may come in a form of maybe 10 dots, maybe 12 dot, let's say 20.5. You may see an IP address like this. This particular IP address that you see is the default gateway, which is the router's number. So if your router begins with this IP address, the first 3 parts of the IP address is the network. So if your DHCP is supposed to assign you the device which you have connected to the network and IP address, the DHCP will look inside the router's IP address and use the parent IP address to assign the other devices that are connected to. Let me give you an analogy. When you were giving birth to your parent, or your parent gave birth to you, by your parents, they gave you a specific name that all of you or all your siblings have that particular name. Example, me, all my brothers and sisters have the name Oduro. This name is our parents' name. No matter what, as long as you are part of the family, you bear this name because that is what came out from my father. This particular name is assigned to anybody with his or her first name. The same thing happens to the router. If you look at the router's IP address, you see that the router is connected to a private network or maybe a particular group of what IP address, either class A, class B, or class C, or whatever. So the DHCP will look inside the router and then assign various IP address to the devices based on the router's IP address. The same thing when I give birth to my children, I will also give them their last name, which is the Oduro, so that they will also add their first name, or I can add the first name of that child. So if the child's name is Seraphine, so she will have this name and then added with what Oduro. The second child will have the name and then add Oduro to it. The same thing happens to routers. Any device that is connected to the router has to share the router's IP address from the address table. And who do this sharing? It is the work of the DHCP inside the router to assign those IP address. And that is what I'm going to explain to you from this infograph. There are 4 steps in assigning the IP address by the DHCP server. And these 4 steps, we normally call it DORA. If you want to remember, this acronym is very good. The first word D or the first letter D is discover. The second one is offer. The third one is request. And then the last one is acknowledge. Let me explain this. Anytime your device, let's take that this is your laptop, want to be connected to the modem or to the router in your house, you remember that the modem is connected already to the wall, which is the direct contact with the internet, which is outside of your local area network, which is your office or maybe your home. After the modem is connected to the internet service provider's connection port, either by a wired, what happens is that the router is connected to the modem and then the router will display or broadcast the network or the internet to every device that is in your home or maybe in your office. Some of them will be wireless and some of them will be wired. In my previous video or lesson, I explained to you what is called local area network connections. We have 2 types, either the wired connection or the wireless connection. Nowadays, in the days of our time, everybody's connection is wireless. So everybody is using Wi-Fi. So when the router is connected to the modem and then the router begins to broadcast the network, every device that you connect to the router has to be assigned a particular IP address so that those devices will be able to communicate with each other on the network where you are sharing those resources. You know, one of the functions of local area network is to share resources and data. So you want this device to communicate to this device, you want other device to communicate to each other. So here, the DHCP uses these steps, which is called DORA. First, the device which is going to be connected to the internet will try to discover a DHCP server. So this device, as soon as you on the device, whether your phone, your tablet, your laptop, your desktop, your washing machine, or anything that uses internet, as soon as you try to on it and try to connect it to the router in your room or even in your house or in your office. This is what the device will try to do. The device will try to discover a DHCP server. Why do you think the router is trying to discover a DHCP server? Example, you want to hunt for a house. You are now going to a city, a town, or a county. You don't know anybody over there. What is the first thing that you do? You need to search online for an agent who can locate you a room or a house or an apartment. Before you get to that place, your room and your apartment is already secured. You do all this arrangement before you move your stuff from your room or your old place to your new place. So here, this is what the device also do. The device will try to discover a DHCP server. So the DHCP server is like an agent, or it's just like someone who is trying to help you to get a home in America or any state. When you get the device, when the DHCP also discovers someone or a device that is looking for an IP address, the communication begins. So as I've used the analogy of how you try to look for an agent or you try to look for someone or a rater who will help you to get a home, the same thing the devices that are coming to join the internet, they also do. Behind the scene, a lot of things goes on, and that's what I'm trying to let you dive deep so that you understand how your devices are connected to the internet. So if you look at the infograph that I have here, this device, whether it's your phone, your tablet, or any device you think it uses internet, will try to look for a DHCP server. Why do you think it looks for it? Because it wants to what? Get an IP address. And without the IP address, this device can never communicate or serve the purpose of joining the network. Any device that does not have any IP address can never communicate on the network. This is the reason why any device, when it is trying to connect to the network, it tries to look for a DHCP server so that that device will have or be registered on the network so that it can also share resources with other devices that are on the same network. Example, your home. So from this drawing that you are seeing here, the device tries to discover, that's where the D comes in. Look for a DHCP server. Now, when this device try, that is number one, the device will try and then broadcast and says that I want an IP address and other network parameters. What are the other network parameters? The other network parameters we are talking about here, one is the IP address. That is the first one. The other network parameter that this device will be requesting for in order to communicate on the network is what is called the subnet mask. The other network parameter that the device will also request from the DHCP is the default gateway, which beginning I told you that if you see default gateway simply means what? The router. And I think the next one that I will add to, so IP address, subnet mask, default gateway, I think these are the most other parameters that the device will be looking for. When we ping a particular network or a device, we'll be able to get more parameters. So this device will say that I want an IP address and other network parameters. This device already have what's called a MAC address, but it doesn't have an IP address to be able to communicate on the network. So for this device to be able to communicate on the network, it needs what is an IP address. The MAC address that this device has is not able to allow that device to communicate on the network. For the device to communicate on the network with other devices, it needs an IP address. So the MAC address that this device have can communicate with each other on a local area network only. Example, your home and then your office. So MAC address will help the devices to communicate in the local area network, which is the LAN. But if the device wants to communicate in the public network, it needs an IP address. And who assigned the IP address? It is the DHCP server that has to assign that IP address to the device that is having a MAC address, so that that device can communicate with other devices on the network. So when this device is able to discover the DHCP, the DHCP will now also send a message and say, here are the parameters I am offering. And these parameters that the DHCP is offering is coming out from the server and then the modem. Remember that the DHCP is also a server because it gives services to devices. That's why we say it is called a server. So this DHCP server will also say, okay, here are my services. It's like, example, when you want to go to a restaurant, you first look at where it is located, which is the discover. When you get to know where it is discovered or where it is located, you try to use Google Map to drive to that place. That's your discovery. When you get there and you enter the restaurant, the first thing that you do is to look for the menu. And you ask for the menu, the waiter or the waitress will come and say, here you are. These are the menu and the services we have here. So over there, you look through the menu and then you make your choices. This is what happens to the device when it's trying to communicate on the network with the DHCP. So the DHCP in step 2, which is the offer, will offer the services that it also gives to devices that want to be connected to the network. So the DHCP will give you the services and the parameters that it has. I will give you an IP address. I have a subnet mask. I have default gateway. Which one do you need and what do you want? But here, during the discovery, the device was asking for other parameters. So when the offer comes from the DHCP, the device will try to look and see whether the parameter that it was requesting for is part of the offer that the DHCP is trying to give to it. This will make things very easy for the device to make its choices. So when the device discovers everything that it needs and it meets his or her or meets its request, then the DHCP will now try to respond back to the device. When you go to a restaurant and then you have your offer or you submit your request, what does or what do the server and then the waiter do? They try to send your request to the kitchen. So here in step 3, the device will say that I have looked at your offer and I like it. So this device will communicate and say that, okay, based on the offers that you gave to me, I've looked into it and then I like these offers. Immediately, the requester or the device accept and then the device is able to accept the offer of the DHCP. The last one, which is the request, is now gone. Then the last one, which is acknowledgement, will come in. This is where the DHCP will say, okay, here are the network parameters. This is your IP, this is your subnet mask, this is your default gateway, and other aspect of information that I'm giving to you. So when you finish eating in the restaurant, what happens? The waiter will bring the bill and then you pay everything. So here, as soon as the DHCP assigns all the offer to the device, then the device is ready to communicate. This is where the network will now start flowing. And then you go to Google, you go to Facebook, and you go to YouTube, and then a whole lot. Without the parameters and without the DHCP assigning you or assigning the device the IP address, that device cannot go to Google. That device cannot go to what? Instagram, Facebook, TikTok, Snapchat, YouTube, and anything that you want to use the device to do on the internet. This is the analogy behind the DHCP's work that I have already explained to you in my previous videos. Now, let's move on to this part. Very, very important. There is a time or it will come to a point that this device will try to request for DHCP discovery. It's like you are trying to look for a realtor to buy a home, to buy a house, to look for an apartment. You go online and you can't find anybody. What happens? You drive to the place yourself and then you try to look around and look for a realtor who will help you to buy a home. The same thing happens to every device when it tries to look for a DHCP server. So here, the DORA, which we have here, which is the discovery for a DHCP server, is broken because there is no DHCP server in the request. So when it happens like that, what happens? The red line is telling you that DHCP server is not available. So if DHCP server is not available, what happens to the client? So here I've explained to you that when you talk about client, it's any device or anything that is trying to look for a service from a server. Your mobile phone, your tablet, your watches, digital watches, and any device that you think it can be connected to the internet is a client. Anything that can communicate on the network is a client. Client begins communication, they begin communication, and then they end communication. So they start communication and they end communication. So when these devices try to look for DHCP server and then there is no DHCP server, what happens is that the device will try to assign its own IP address. And when the device assigns its own IP address, we call it IPAPA. What is IPAPA? IPAPA stands for automatic private IP address. So if you hear IPAPA, IPAPA simply means automatic private IP address. So the device will try to assign an automatic private IP address to itself so that it will be able to communicate on the network as well. And then that IPAPA address begins from 169.254.00.0 to 169.254.255.255. So if you check your IP address and you see the IP address begins with this 169.254.0.0, from this IP address range up to this IP address range, then it means that there was no DHCP server. So the device has assigned an IP address to itself. This is where we have the contradiction called the IPAPA. So the IPAPA simply means automatic private IP address. It occurs when the device tries to discover a DHCP server, but here the DHCP server is not available. So the offer, the request, and then the acknowledgement are all broken. And when it happens like this, the device will try to assign the IP address to itself from the address range 169.254.0.0 up to 169.254.255.255. This is what happens when the DHCP server request and then discover and the offer and the request and the acknowledgement is no more available like what I've explained to you here. So in the DHCP server configuration or in the DHCP server request, these are the steps: discover, offer, request, acknowledgement. I've explained this to you. Let's go here. So how DHCP works, I've explained to you. So here you can see that there are 4 steps that goes on as I've explained. So the DHCP is discover. So a device broadcasts a message. Is there a DHCP server? The goal is to request for an IP address and other network parameters. That is step 1. Step 2, the DHCP server offer. So the DHCP server responds with an IP address and configuration details. The configuration details are what I said: the default gateway, the subnet mask, and then the other parameters. So here the message is that here is an IP address from the DHCP server. So the DHCP server will say that here are different types of IP addresses with their parameters. Then the device will make a request. Okay, the device requests a specific offer from the preferred server. So the server that the DHCP server is also responding from will also give all the services, and then the device will choose, this is my request. So I would like this IP address, please, and then other things. So here the device will make a choice of the IP addresses that it has, and then the DHCP will say, okay, acknowledge sir, or acknowledge mom. So here the server confirms the assignment with the DHCP server acknowledge message. So the IP address assigned successfully, and then the device can now communicate. Go to Google, go to Facebook, TikTok, Instagram, and then other network places that the device want to visit. This is what happens, and this is the work of the DHCP. The DHCP is very important because the dynamic host configuration protocol works in such a way that the device will be able to assign a particular IP address within the local area network so that that device can communicate with other devices on the network. This is how the DHCP works. There is a demo that I can show you how the DHCP assigns. So in the DHCP assignment, here we have two ways of configuration. The first one, we have what is called the automatic configuration. And then the second one is the manual configuration. The automatic one, the DHCP will assign the IP address automatically to the device. The manual one, we have to assign the IP address manually by ourselves. So if you pick up your phone and then you go to settings and then you go to network and then you go to the name of the network you have connected, whether the Wi-Fi, and then you click on the small I with the zero or a round around it, and then you scroll down, you will see all the configuration and you will see that the DHCP is automatic. I will explain to you in the next demo that I'm going to show you right now. Watch out and see this in my next video that I'm going to show you how the DHCP assigns the IP address to the devices automatically, and we can also do a manual configuration. So in DHCP configurations, we have two steps. There are two configurations. So the first one is automatic assign, and then the manually assigned. And that will be the next hands-on video that I will show you very soon. All right.